The topic of this video is building quadratic models from verbal descriptions, economic models. Let's look at a problem. The price P and the quantity X sold of a certain product obey the demand equation P equals negative 1/6 X plus 100, with 0 less than or equal to X less than or equal to 600. Part A, find a model that expresses the revenue R as a function of X. Part B, what is the implied domain of R? Part C, what is the revenue if 180 units are sold? There's also a Part D and a Part E, which we'll do in our next video. All right, let's jump in with Part A. Find a model that expresses the revenue R as a function of X. This means that I need an equation that starts with R equals, and the only variables that are allowed on the other side are X. Finally, it also has to be a function so that we can write it as R of X. Let's see if we can achieve that. We're going to start with a familiar equation. R is equal to X times P. R, revenue, is equal to the quantity sold times P, which is the price. In this problem, we are told that P is equal to negative 1/6 X plus 100, and we can substitute that into this equation. Then we can write R equals X times, and instead of P, we write what P equals, negative 1/6 X plus 100. Notice we're getting closer to our goal. We have an equation that starts with R equals, and the only variable on the right side is X. We're going to use the distributive property. Then we'll have negative 1/6 X squared, because X times X is X squared, plus 100X. We notice that this side of the equation is quadratic in form. Quadratic expressions are functions. Therefore, instead of simply writing R equals, we can write R of X equals. This is function notation, not multiplication. Revenue as a function of X, R of X equals negative 1/6 X squared plus 100X. All right, that's the end of part A. Part B. What is the implied domain of R? All right, well, domain is the allowable values of your input for your function. In this case, the variable is X. So we're looking for what are all of the allowable values of X. Good news, it's given to us in the problem. These are the allowable values of X. X must be between 0 and 600 inclusive. So our domain is bracket 0, comma, 600, bracket. Part C, what is the revenue if 180 units are sold? Well, the nice thing about having an equation, a function like this, is it tells you the relationship between one variable and another. In this case, X, the units sold, and R, the revenue. So if we want to know what the revenue when 180 units are sold, we just have to replace each X with the number 180. So we get R of 180 is equal to negative 1/6 times 180 squared plus 100 times 180. At this point, we have to be careful. We know that order of operations tells us the order that we should follow in order to come up with an answer to this particular numerical expression. Exponents come first, so the first thing we're going to do is 180 squared. So 180 squared is 32,400. So we have negative 1/6 times 32,400 plus 100 times 180. Okay, the next thing we're going to do is the multiplication. We'll take 32,400 and multiply it by the fraction negative 1/6. That gives us negative 5,400 plus 100 times 180 is a 180 with 2 extra zeros at the end. And now we add those together. And we get $12,600. Okay, so we've completed parts A, B, and C. This is the answer to part A, express R as a function of X. This is the answer to part B, what is the domain of the function R? And this is the answer to part C, what is the revenue if 180 units are sold? We'll now move on to our next video.